Okay guys, so now that you have this first part, okay, we just check the setup. Everything is just as the previous video, but now I'm going to change a little bit. I remember in the other one we had selected 2D Pocket. I verified it and it will not work, so we need to check 3D Pocket Clearing. Okay, so this is the one we'll use. Just delete the other one. So we'll just go here to Pocket Clearing, and in Tool we also need to select to change the parameters for the tool. Okay, so I check out, and the tool for 3/16 was too small, so it would take a really long time. So just whatever it says on your original one, just click Delete Tool, just click OK, and we'll basically put a new tool here. Okay, so again we click here, and now description, cortador, bola, half an inch. Okay, and then in the cutter it will be again a ball end with 4 flutes in inches, and in this case it's gonna be half an inch in diameter. Okay, the rest stays the same, just 1000 RPMs, and that's it. Click OK. Now we have this cutter, which is way bigger than the previous one, and this will make things faster for machining. Okay, so just be sure to change that one and click OK, and that's it. Okay, so the next part is the geometry. Right now, the machining boundary will define basically the perimeter of our tool. So here we click on selection. Okay, and we'll basically select our perimeter of our cutting. Okay, and here the tool would be inside the boundary. Okay, just be sure to verify those things with no offset, and the rest is just click it's left unchecked. Okay, so for geometry, selection, change tool inside the boundary, and be sure it looks like this. Then we go here to the heights. Clearance height, we'll just leave it here with an offset of 10 millimeters, retract height 5 millimeters, and the rest, the top height is the stock top, and bottom height is the model bottom. Okay, so just leave it as it is, and then, or at least be sure that it looks exactly the same as this one. And then in passes here, the tolerance, just leave it like that. Minimum diameter here, here in minimum cutting radius, right, which it says here, we'll just put about 2.4 millimeters. Okay, or maybe 2 millimeters. Okay, 2 millimeters is okay. No, actually this could be way higher. We could go all the way to about 6 millimeters, but let's make it 2. Okay, so this will give a better roughing finish, and then roughing step down. So this means how much can it go down in the set direction on each pass, and we could go all the way to around let's just say 5 millimeters right now. Okay, so basically be sure this stays like this, 1.0 minimum diameters, which just leave it at 0 as well. Cutting radius 2 millimeters, direction climb, roughing step down 5 millimeters, no stock to leave, just uncheck that, and everything left unchecked as well. And here linking, just leave it as it is, just forget about this last part. Okay, we click OK. It says that the step over should be set manually. Okay, so I'll just go here to step over, click on it, and then cutting radius again 2, and maximum step over, let's say this can be way bigger, about 6 millimeters. Okay, and here let's just put about 1 millimeter. That's it. So it should look like that. Okay, if you go to tool, it has to be half an inch with 1000 RPMs, and this should look like this one. Then in geometry, selection, chain, tool inside the boundary. Here it should be 10 millimeters clearance height, 5 millimeters retract height, and the other one's in 0. And here in passes, just be sure this looks exactly like this: 0.1, 0, manual step over checked with a minimum cutting radius of 2, maximum step over of 6, minimum of 1, climb, and roughing step down 5 millimeters. We click OK, and no warnings right now. There's a small warning here which says lift and retract plane to safe plane, so that won't make an issue. And so far we just leave it like that. And what I want to see actually is the simulation. Okay, so let's see if this thing can actually behave as it's supposed to behave. So just right click here and go to simulate. Okay, and in this case click tool, but just the flute, because if not the shaft, well, it could be all the way to the shaft. Then toolpath, we don't want to see the toolpath right now, and click in stock mode, standard material ceramic. Okay, and we basically check the info here and we'll see how it works. Okay, so in the starting position is at plus 15 millimeters, so 15 millimeters above our surface, right? And this would be the final path that we will see. Okay, so we'll just click play in this part here and see how it behaves. Okay, so you can see here how the machine is moving, right? You'll see that it's at minus 5 millimeters right now and moving in X and Y direction, right? Now it's at minus 10. This means that each pass it will go down 5 millimeters in Z direction. This makes everything go faster. Okay, and since we are cutting wood, this should be more than enough. Okay, so here you can see the simulation and you can see basically the path that it will follow. You can see, for example, in these corners, since our tool is, has a radius, right, it will leave this sort of radius all the way, right? So if you have sharp edges like these ones, it's not going to be possible to machine them, but it will basically look something roughly like what you're seeing right now. Okay, and here basically we can see all the statistics about the machining time, which should be around 23 minutes, right? So it's not that much. And here you can see how it's moving around. Okay, so we'll do some tests, but what I want you to hand me in is this sort of simulation, right? So I can be sure that this thing looks as this simulation. Okay, it's almost done. Okay, and let's see how much time left. Not much. Okay, so this is how it might look if we are doing steps in the Z direction every 5 millimeters. Okay, if these steps are smaller, then obviously the finish would be more smooth, but it will take longer time. Okay, there you go. So just in order for you to get a glimpse, if I change it here, click edit, and in these passes, instead of being a 5 millimeter step down, I click like 2 millimeters step down and then click OK. The simulation restarts and I just go to simulate, right? I can click play. Let me just show the stock like that, and I'll just have it move faster so you can see the difference. Okay, now you see how the steps are way smaller. Okay, leaving a smoother finish, but it will take a bit like twice as much. You can see 47 minutes instead of 23, but the finish is way better. Okay, so far what I need you to have is this sort of simulation, and then basically once you have this, I will validate each simulation for each team, and once each simulation is being validated, then we can go on to generating the code. Okay, so I'll show you how to do it, but I'll need to verify that this simulation works properly before actually moving to this part. Okay, so we just simulated it, and then we just click here in post process, right? So just click here, and then generic post. Let me just check that. It's Boxy and then the program number. So here, generic posts, and instead of being Fanuc, we need to go for Boxy. Okay, this is our program number before, and these are these things, document unit, and then click here in properties. Okay, and be sure that these properties look similar to, sorry, I'll just put it around here, okay, click preserve rapid movement 0, 1000, the minimum chord length, you can leave it like that, 0.1, 0.002, click 1, 2, and check. Okay, so everything looks like the manual I just created early. So just click OK, save it, in this case as .nc, and we'll save it, for example, in desktop. Okay, and you click save, and then if you go to desktop, you can find it here. Let me just open it, for example, with text edit. Okay, well, it opened in this other editor, which is called brackets, but if you're in Mac, you can open it in text edit, and you can see here it starts at 000, and then it goes all the way down, and you can see here is the line number, line 5, line 6, line 7, 8, 9, 10, etc., all the way to 54,970 lines of code. So you can see there's a lot of code, but everything was done automatically by the machine. Okay, now this is the case for 59,000 is the case for using a 2mm roughing pass. Here you can see, but if I switch again to 5mm and click OK, everything goes again, and then again post process, this is right, I click OK. In the same one it will replace it. I'll click OK, and then it opens automatically in this browser here, and you can see from 54,000 we went to 31,000. Okay, so it depends a lot on the layers. This is similar to the 3D printer, depending on the layer height, basically, of the resolution of our final machining process is the number of lines. Okay, so it's better to have less lines because this will take a shorter period of time to create. Okay, so basically this is what you need to do. Check video 1 and then this video 2, and I'll just put the different tools that we have available in the lab, but I will definitely suggest that you use this one, the one that has a 1/2 inch in diameter. Sorry, it's here. So it's this one, right, which is basically 1/2 inch in diameter, and it has the shape of a ball, a rounded end, okay, with 4 number of foot. So I would definitely suggest you use this one. All right, so click yes, okay, and basically nothing changed. Okay, just be sure to save it. Okay, and that's it. Thanks a lot, guys.